Hello everyone, I'm MD Saqib Alam and I'm really delighted to present our work that we have done for last whole day regarding the assessment automatic usages of AI in the education sector, especially the marking assessment and automating the grading system of the student. So we were very intensive work regarding getting the possible solutions and the base business model that we can integrate to our solution. And we finally came up with a solution that would give us some feasible results regarding the assessment of students. So nowadays we can see that nowadays, especially in online education, as the number of students is growing, especially in the international education sector, it is more tiresome for the teachers to get insights or to get track of all the students, their results and grading them. And also it's cost their valuable time regarding grading their paper, taking the assessment, scheduling, doing administrative work. Also, they have to plan the lessons. But now we are living in the age of AI, and we have many very good machine learning technologies along with very high-powered compute engines. If we can and many data sets, if we can leverage these two technologies and fuse them, we can come up with a very good AI-enabled assessment marking. So that's what we have done, but in a prototype version to our project. And I would like to delegate to my next friend, Tawhidur.
Hello, this is Tawhidur Rahman Abdul, and right now I'll be talking about our problem statement. So due to the pandemic situation, a lot of people have been giving exams online, and there are a lot of exams that have a set of questions that are being repeated every day. And but still, the faculty has to go through each and every one of it to mark, which can be really tedious. So the solution we're providing is a method that automates that checking and gives the score. The faculty just needs to input a student's answer and the question number of that specific essay, and our algorithm will grade it based on the previous graded answers. So at first, let us look at the dataset. So the dataset mainly has 4 fields: essay ID, essay, essay set, which is a question number, and a score. From a glance of the dataset, you can see that the dataset is highly imbalanced. Most of the points are in set 2, whereas the least in set 8. From a primary analysis, we can see from the box plot that the data has a lot of outliers, specifically the 7 and 8 dataset, which can be a problem to us. Let's remove that. And then we can also see that in 7 and 8, the marking, the mean, and the interquartile range are very similar, which means there might be a chance of plagiarism. From the vocab count and scores, we can see as the number of vocab increases, so does the score. It is a positive trend. Whereas as the number of wrong spelling increases, the score decreases. So our approach is an ensemble technique, which means we will combine the results from two algorithms to accurately scoring the essays. So let us go deep into the algorithms. So the first algorithm is based on similarity matrix. So the first thing that we will do is take all the essays, the essay answers, and divide into 8 parts. Each part will be corresponded to a fixed set of that essay. As there are 8 set of essays, we'll divide the dataset into 8 parts, and each and every part will go through a different PFIDF vectorization. So when the user inputs the essay and the set of essays, the essay will be converted into a TF-IDF vectorizer using the vectorizer of that set of essays, and then a cosine similarity will be found out. And then we'll give the mark of that specific essay, which has the highest cosine similarity. And also we'll return the similarity, which will be helpful later on. So the algorithm 2 is more based on a classification algorithm. The first thing that we'll do is we'll take all the essays and we'll use some features like we'll actually extract the features like vocabulary count, the number of nouns, the number of verb, adjective, adverb, the percentage of wrong spelling, and we'll discard the exact essay, the writing, piece of writing, we'll discard it. Then we'll divide the features into 8 different sets based on the set, similar to that of the previous algorithm. Then we will convert them into a standard scalar and then pass through SVMs. Note that in this algorithm, each and every set will have a different SVM algorithm set to it. We have done it so that we increase the accuracy. So each and SVM will be specialized to classify that specific set. So when the user inputs as essay and SS set, the first it will do some feature engineering and it will put the features into an SVM of that specific set and get the output score. Finally, our algorithm will take both of the output scores from the TF-IDF and the classification algorithm, and we'll make an average and get the ceiling value of it. That means if it's 4.5, it will get 5. It will also return the similarity. So the advantage of it is measuring the similarity ensures that the marking is consistent with the previous marking. Also, as we are getting the similarity, we can see, and if the similarity is very high, that means 80%, 90%, we can say that there might have been a plagiarism or cheating. So, and we are adding the classification to further reinforce the algorithm. The classification algorithm will penalize for low word count and for the spelling mistake. So now let us go through an overview of the code. So let us go to the code. So after importing the libraries, we'll be using the data set that have been formatted already. With when we have figured out the word count, particular count, noun count, etc. We will need these values for a classification algorithm. We'll be using them. So the first thing that we'll do is divide the data set into two parts. One for the cosine similarity, another for the classification. For the cosine similarity, we're using three variables: SA, SSF, and score. So after some preliminary pre-processing, the first thing that we'll be doing is divide the data set into 8 different parts, depending on the sets. And each and every set will have its different specific TF-IDF vectorizer with n-gram of 2 by 2. So after that, we'll also write some function for pre-processing the input user input. So depending on the example user set, depending on the set given by the user, we'll select the TF-IDF vectorizer and find the cosine similarity between it. And finally, we'll give the maximum of the similarity and the score of that similarity of that vector. Then we'll work for the classification algorithm. So the first thing that we'll do is we'll take the rest of the data set, that means the word count, vocabulary count, noun count, verb count, etc. And we'll divide it into 8 different parts, just like previously for the TF-IDF vectorizer. Then we have tried 3 different scalars: MLP classifier, random forest classifier, then SVM classifier. And among them, SVM gave us the highest result. So we are using that. So each and every data set will be fitted into a specific classifier, and the training will begin. So then the user input will be formatted exactly as it was formatted previously in the data set, for figuring out the word count, the number of noun, verb, adverb, etc., and the spelling check. And after the pre-processing, the feature will be extracted and it will be scaled according as the input in the training set has been also scaled. This will have to be scaled. Then the classifier will predict the features and give us an answer. This get final prediction classifier gets the prediction from both the similarity and the classifier and gets the average of it, and finally returns us the average score and the similarity. So as a test, this is a piece of writing that has not been actually trained on. So the first thing that we can do is first we see the prediction. So it comes very good. So now let us see a UI that we have built. We have used Tkinter for building the UI. So as you can see, this is the UI that we have built. So we can fit the text data and the class from the set of the essay, and we search for it. And you can see it has given us the result and the similarity. So let us check if the result is correct or not. Remember that from the result is 4. That means as it is the 8th question, so it was previously scaled from 30 to 40. So the value, if the value comes from between 30 and 40, then it's correct. So this is where the data set comes from. So this is the part where we have taken, and you can see that it has come to 30. That means the result that we have received is correct, even though we have received a small similarity matrix, but the algorithm has correctly classified it.
Hello guys, now I would like to describe the feature scope of our project. So we have come this far that we are using the similarity and the score that our overall model, like from the SVM and also from the cosine similarities, we have gathered these 2 metrics. But in the future, I would like to integrate more and more data to our system. So for that, we can use LSTM, long short-term memory. It's kind of a recurrent neural network to use to instead of, like, we can use the base feature extractor using this. And I have come up with some very novel approach. Like we would make our own variables, metric variables. That would be like each questions and the answers, their context. Like we are coming with some kind of sentiment analysis. It means like it would find us sense of similarity between the two. We would add that layer of classification before we train this model. So our model would be very real time and very practical. Also, we are trying to make it implement in our mobile phone. So I'm currently working on Android Lite, TensorFlow Lite. So we would deploy it in phone, so the teacher would have they would find it very easy to work on the mobile. So from the mobile, all the servers or the database from the servers would be uploaded to the mobile, and from the mobile they can see the students' progress and their academic everything. So I think that would be that our future process. Like we are making a hybrid that would include mobile, tablets, computers, laptops, everything. So this is and we are including parallel processing if we are getting our data in big size. So our plan is to get the data from the database of universities, and yes, that's our future scope. And our business model, basically our project is very much like in favor of the economy of any institution. For example, we are very feasible, we are very fast, reliable, and accurate, because it happens. Our teacher sometimes is, for an example, he could be low in mood or he could be very tired. So grading process would be quite difficult for him, but we can assist him in this project. It will be quick deployment and it will be high feedback mechanism. So there will be feedback and the model would continuously evolving. We have economic value. It's a very cost effective because we are using the lowest amount of, like we will be deploying in future in the cloud. So many of the cloud services are really cheap and very free. We are making automation. So automation, like we don't have to deploy other people to manage it. So it will be managed automatically. It has a good societal value. So the students, there will be a transparency. The results would be non-biased. There will be less prejudice. It would be just technology oriented. And the teacher who can utilize their time that they were spending on marking and planning, all those things, study things, on teaching the students and having good time with them and having good relationship with them. And it's very sustainable because I think this is the future of education. And by this, like we have the capabilities, by leveraging AI capabilities, we can attempt, have minimize, and we can like eradicate the manual grading system, which has some flaws over this model. Yes. So process flow diagram. So as my friend mentioned that we all had tried to work on two strategies. First strategy was to make a similarity, and the second strategy was to come up with an algorithm, kind of classification algorithm. We tried neural network and like NLP, other SVM, other machine learning algorithm, but SVM gives us the highest score because we have done some kind of feature extraction and everything. And in the similarity score, we work on the vector similarity score, and then we come up with the idea that let's make an average of both of them and mean them, and that would be our final score. So it was like in practical sense, it makes sense that if we use the mean, it would be much more similar, and that's why we can get the final score. Can you go next? Conclusion. So all I can say that AI is revolutionizing the way students learn and teach. So it is a very great potential to doing administrative work, not in for academics, but the document processing, the academic document processing, pay slips, invoices. We can do it in very short amount of time. And the global AI in education will reach 5 billion by 2025 and compound annual growth of 45%. So it's a very emerging market, and it can be very crucial to dealing with data assessment. And maybe in future we can see that there would be, instead of single teacher or centralized, there would be on the cloud, on the environment like Google, Microsoft, Amazon. They would provide the teaching assistance or everything. In future, it's a possibility. Or maybe for the new startups, they can connect with universities regarding the marking assessment and everything. So yeah, so I think in the future, teachers' jobs going to be very easy, and they would have more time to really have engaged with the students. Thank you so much.